This is part 2 of section 1.5. We want to graph the function starting from a function in the library that we have. I'm going to bring that information back up in just a second and make the necessary transformations. So if we want to graph h of x is equal to the absolute value of x minus 2, we first need to find the absolute value of x. We need to find that graph. And it is right here. It comes to a very definite point. It is the constant function, not the constant, the identity function here, not down here. And then it is reflected over here. Okay? And we are at 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, and so on. Okay. So I know my basic graph, and I'm going to put some points on this using just a pencil so that I can see my original. And this will help you some, especially if you're doing things on paper. Okay, so those are just some of the points on the absolute value of x graph. Now I need to look right here. I have a minus 2 and it is inside of my graph. So this is a horizontal movement. This says minus 2. So I'm going right 2 units. Okay, so I take this point and move it right 2. This one, go right 2, right 2. You're just shifting all of them over. And then you'll find that you have enough points for a graph. Okay, and then you've got your graph, and you're done. Okay, so let's write an equation for the function whose graph is the same as the graph of the square root of x, and we're going to shift it 3 units to the left. Okay, so if I'm shifting to the left, that means it's going to go inside the square root. So I'm just kind of, I'll rewrite this if it's ugly. I need to do something inside this. And if I'm going 3 units, it's going to be a 3. Now, is it plus or is it minus? Well, inside, it always seems backwards. I want to go left. So that means I need to use a plus sign. And then the answer they're looking for is y is equal to the square root of x plus 3. That would be the graph of the square root of x moved 3 units to the left. Okay, so those are our vertical and horizontal shifts. Those are some of our rigid transformations. 2 more of our rigid transformations are the reflections. So basically, we are going to be flipping our graph either over the x-axis or over the y-axis. And it all has to do with a negative sign. If there is a negative somewhere in there that has been introduced, then we are flipping our graph somehow. And it's all about where that negative is placed that determines what we do. So reflection about the x-axis, which I have labeled as an outside, which I hope you would recognize means that the negative is going to be on the outside of the function. Okay, so if we have a negative on the outside, we're going to be flipping our graph over the x-axis, which means that we're flipping it vertically. It's an up-down flip, and we're flipping it right over that x-axis. Okay, so this is an up-down flip, or a vertical flip, which is outside. Reflection about the y-axis, so we'll be flipping it along that vertical line, so this is a left-right flip. And here, I have it labeled as an inside, and you can see that the negative is inside of the function. So even though it says we're flipping over the y-axis, if you think about it too much, you can confuse yourself. But since the negative is on the inside, it is a horizontal flip. We're just going to flip it left to right. And the horizontal shift was an inside, the vertical shift was an outside. So we have some consistency here. okay? So let's describe the transformations that produce the graph of G and H from the graph of F. Now, we haven't talked about this too much yet because we still have one component that we haven't talked about yet. But there is a definite order we are supposed to do these transformations in once you add something beyond a vertical and a horizontal shift. Okay, so what you want to do first is that horizontal shift. And then our second step so far, we're going to add more things later. The second is the reflection. And then the last thing we're going to do is the vertical shift, if there are any. If all you're doing is shifting all the horizontal and vertical, it really doesn't matter which one you do first because you're going to end up in the same place. But once you start flipping things over an axis, it really does matter where your graph is at that particular point. Okay, so let's look at this. I have, my original is x cubed, and I don't see a negative introduced anywhere in here. This is just regular x minus 2 cubed plus 1. So I have the addition of a subtraction or an addition inside the function. So this is a horizontal shift of 2. And since this is minus, it's going to the right. So that is right 2. This is outside of our function, so this is up 1. Now let's check this one. I have a horizontal movement, I have a vertical movement, but I also have this negative on the outside. So this, on the outside, it is a vertical flip, which is over the x-axis. So horizontal shift first. That's coming from the 1. This is a plus, so we're going to go left 1. And then we take care of the reflection, so we're going to go reflect over the x. And then finally the vertical shift and go up 2. Okay, let's try this one. If my original function is the square root of x, here I want to talk about how to graph this, how to move things. I have negative square root x plus 1. I first look for a horizontal shift, and I don't have any on either of these, actually. It's just x. It's not x plus anything or x minus anything. So on neither of these do I have a horizontal shift. But I do have reflections. Here, the negative is on the outside, and outsides are verticals, so this is a vertical flip, which means that we're going to reflect over the x. Then we deal with our vertical shift, and we go up 1. For this one, the negative that was introduced is inside of the function, so this is going to be a left-right flip, which is reflecting over the y-axis. And then deal with your vertical shift to go up 1.